Welcome to our next series of lecture. In this series of lectures, we'll be focusing on SmartPLS. Now, SmartPLS is a modern tool that is used to develop structural models. Uh, there are other alternatives as well. It just says maybe you can use M+, you can use AMOS, you can use Lizrel, or other softwares like Stata. But um, SmartPLS, the best thing about SmartPLS, it's really easy to use, and this is what makes it particularly more advantageous. It can give you, or you can develop complex model in SmartPLS. You can readily check the reliability and validity of the constructs. There are some downsides. It's not a confirmatory factor analysis based software, so you cannot do confirmatory factor analysis to the extent that you can perform in AMOS or other softwares. Uh, Another thing that it does not assume normality, so then there's no problem of normality assumption, so you do not need to check for normality assumptions. A number of papers are using SmartPLS these days. Let's start with SmartPLS. Now, SmartPLS does not take XLS files or the SAV file, the extension of SPSS. It takes comma separated version. So you need to first save your data into comma separated versions. Now you can easily do this if you have saved your data in SPSS. Just click File, Save As, and then save it in CSV format. Or you can do it in Excel as well. Just go to File, Save As, and save it in CSV format. Now, what you see in front of you is the screen, is the SmartPLS software. On the left side is the Project Explorer, where you will see all your projects. Underneath, you will see the indicators. These indicators will show once you have the data loaded or you have selected a particular project. Now, to make one project or start a project, you click New Project, and then you name a project. Always try to give a meaningful name. For instance, in this case, let's say I'm working on CSR, team outcomes, or let's say organizational performance. Press OK, and if you see here, a new project is created. Now, there is an exclamation mark. This means that it's not yet ready to build. So what you need to do is you need to double click and import your data wherever you have saved your data. So in this case, I've saved it in one of my folders where I was working with my students. So here is the CSV file, data file SPSS. Okay. And this means that you have successfully loaded your data. Now, these are the descriptives, demographic profile, the gender, the experience of the people. There's no missing data. This is mean, median, minimum, maximum, standard deviation, excess kurtosis or skewness. If we see, well, do not see any problem with skewness and kurtosis for most of the variables, but there might be some. Let's see this, okay, here. But obviously, since it does not require normality, so we are good to go. So let's see, if we double click on this, we'll see the canvas. And on this canvas, we will be building our model. Now, let's say we are interested in identifying, and we are building just a basic model, and we are interested in identifying how CSR influences organizational performance. Now, in our case, CSR is measured using 4 dimensions. And let's assume we are interested in identifying the overall impact of these 4 dimensions or CSR on organizational performance. So what we do is we select these items, we drag them and drop them onto this canvas. So once you drop them, you will see this red circle which says latent variable. So this is the unobserved variable. And all these variables in yellow are the observed variables. Now, if you see the arrows, they are pointing from the latent variable to the indicators. So I am taking this variable as a reflective construct. So CSR is actually reflected in these items. So what does this reflective indicators mean? So if I remove one of them, any one of them, this will not inhibit, or this will not um, obviously lead to the issues of content validity, because sorry, CSR is reflected in all these, or in these items. So the only way these items are deleted is once they fail to represent the underlying construct. But we will come back to that later. Okay. So how do you rename it? Just right click on it, or either press F2, rename, and this is CSR. So and then we are interested in assessing its impact on organizational performance. These two are reflective construct. Right click on it, rename it as organizational performance. And we can set the indicators to the right, align indicators to the right. And we can obviously do some more setting by clicking the snap button so that they are aligned perfectly together. Now, how do you connect these two variables so that you can run your model? Now, in order to do this, you press this connect button here on the toolbar, and then click on CSR and drag the arrow to OP and click on it again. So it's dropped on OP. So now the model, the red circles have turned blue. This means you are ready to run the model. Now CSR is influencing organizational performance in this model. And now we need to assess or evaluate whether our hypothesis that we proposed stands true, or is it false. Now, in order to do this, or in order to run the model, what we do is, let's say, calculate PLS algorithm. So you are presented with a dialog box. And in setup menu, you can see centroid, factor, or path. Okay, before we go with the path analysis, there's one thing that I need to obviously elaborate. Now in SCM, a model or a structural location model is divided into two different models. One is the measurement model, which we can say is the outer model. And the other is the structural model, which is, we can say, the inner model. In measurement model, we assess, evaluate the quality of the constructs. We are interested in finding out how reliable and how valid are our constructs. Now, to evaluate the measurement model, or to evaluate or to conduct SCM, we first perform measurement model analysis. So we know that our model, or sorry, our constructs are reliable and valid. Before going on to the path analysis or evaluating the impact of CSR on organizational performance and assessing whether CSR does actually impact organizational performance, what we need to do is we need to actually identify whether CSR is a reliable and valid construct, and whether OP is a reliable and valid construct. Now, in order to do this, sorry, we press calculate and we click on PLS algorithm. Now, in the setup menu, we are presented with centroid, factor, and path. In this case, we will select factor because we are interested in identifying whether the factors have got quality, whether or not the factors are reliable and valid. Maximum iterations, you can, the recommended is 500, 1000 as well. So you can or leave it as it is. It doesn't, won't create any problem. But if it does give you any problem with respect to iterations, or it says that, okay, the iteration limit was reached and the results won't produce, so you can increase the iterations. Go to weighting. There's nothing you should do here. Just plain simple, just press start calculation and it will open the full report for you in a second. Okay, here are the results. Now, we are first interested in finding out whether the constructs that we are using in this study are reliable and valid. So if you see this quality criteria, the third item in this quality criteria is construct reliability and validity. If we click this, we see that all of them are green except for average variance extracted. Now, this does happen when you have a construct that is already divided into dimensions and you take it as a whole, you will have or you will experience this problem. So we'll be discussing on how to solve construct reliability and validity issues in SmartPLS soon. But for now, it's just our basic model. So we are not going into detail of how to solve construct reliability and validity problems, but that will definitely come later. In this case, we see that AVE value is less than 0.50. Now, the recommended AVE value, average variance extracted, is less than, sorry, it should be greater than 0.50, but in this case, it's less than 0.50. In other, the OP is good, it's over 0.50. Now, what is reliability and what is validity? So we'll be discussing this as well. Now, if we see here, what are these numbers that we see right over these arrows that are pointing to our indicators from our latent construct? Now, these are loadings. These are factor loadings. Now, if we select one of them, and let's try to understand what this means. Now, this 0.50, the recommended value it should be greater than 0.70. But in this case, if we see that most of them have got low loadings, very few have got greater than 0.70. So what does it mean? So 0.50, it means how well loading, the basic concept of loading is how well a particular item is representing the underlying construct. So in this case, it's 0.50. So it's you can say that it's just like it's 50% representation is being done by DC1. But while the expectation is that it should be well enough, it should be over 70, 70%. In this case, it's 0.50, so it's low. It's low for DC2, it's low for DC3, it's low for DC4, it's low for DC5. So all these 5 items that actually help measure discretionary citizenship or discretionary behavior of the organizations, they are not representing the underlying construct well. So what happens when the loadings are low? The recommended option or the recommended technique is that you have to get rid of items that have low loading. Reason being that they are not representing the underlying construct well. Now, why do you want to delete them, or will you delete all of them? If you delete all of them, then obviously there will be content validity issues, because in your literature or in your introduction, you might have defined CSR as something that is comprised of four dimensions, but now in your analysis you are removing one dimension altogether. So you can't just go on this deleting spree and just keep deleting your indicators. So we'll be discussing these in our coming lectures, so stay tuned. Now, and as far as OP is concerned, all indicators have loading over 0.70, so this is good enough, as we saw in this construct reliability and validity section. Now, the other, or actually reliability, is there are 2 forms of reliability. One is convergent validity and one is discriminant validity. Now, what is convergent validity? Convergent validity means that whether or not these indicators are converging, are coming together to measure the underlying construct, which is OP. Now, their average variance, how well they are representing this construct OP, should be greater than 0.50. So if the AVE value is greater than 0.50, which is calculated based on these loadings, So you can say, yes, these indicators are adequately representing and are showing convergent validity because they are converging, they are coming together to measure this construct OP. But in this case, as we saw that the AVV value was low, so we cannot say that these indicators are actually coming together to measure this underlying construct CSR. So this is all about convergent validity. So whether or not these indicators are coming together to measure the underlying construct, are they adequately representing the underlying construct? Are they performing their duty to measure, to do what they intended to do? And that was to measure CSR. So this is convergent validity. Now, what is discriminant validity? Since we've got two constructs in our model, and we need to establish that these are actually separate or differentiating constructs. They have got their own entity, they have got their own representation. So in order to assess whether these two constructs are actually different from each other, and this is because we need to establish that, okay, yes, they are different constructs, and that's why they should be dealt differently and measured differently. And that's the reason we should assess the impact of one on the other. So how do you do this? There are multiple means to do this. If you go to discriminant validity, you will see three options: Fortran and Locker, cross loadings, and heterotrait, monotrait, and ratio. We'll discuss just one in this session, and we'll be discussing more in the coming sessions. So if we see CSR, we see there is one value 0.540. And then there is this another value right underneath this 0.540. So what is this 0.540? This 0.540 comes from this AVE. So if we take square root of AVE for CSR, this will amount to 0.540. So if we take square root of 2.292, this will be 0.540. So this is 0.540. Now, how do you establish discriminant validity? Now, this 0.540 or the square root of AVE should be higher than all the underneath or underlying values. And in this case, we have got only one value. Now, what is this? This is the correlation coefficient. So the correlation between CSR and OP is 0.497. So your square root of AVE should be greater than the correlation between the constructs. So in this case, 0.540 is greater than 0.497. So this means that discriminant validity is established. Thank you very much for listening.